Hello everyone, this is our course project for the course Pattern Recognition and Machine Learning. The title is Twitter Sentiment Analysis and the group members include Saumitra, Agarwal, Krishna, Patil, Gouri, Patidar, Mukund, Gupta, Aarohi and Harshit. We will quickly going over the problem statement. We can see it is to perform sentiment analysis on a dataset comprising of tweets by applying classical machine learning algorithms and classifying the tweets as short strings of text as either conveying positive, negative or neutral emotions. Going over the dataset, we can see that it contains over 30,000 data points, each of which contains features such as text ID, time of tweet, age of user, country, population, land area density, and finally the label, that is the sentiment. We can see from here that the dataset contains no null values and it is complete. And also looking at the different counts of feature values, we can see that the dataset is fairly uniform. Quickly describing the data pre-processing procedure. In data inspection, no missing values were detected, and outlier analysis involved ignoring features with outliers which were irrelevant to the sentiment analysis. Categorical encoding was done, and in text pre-processing, what we did was we converted the text to lowercase, and also stemming and stop word removal was done using NLTK. Data vectorization included utilization of BERT tokenizer and TF-ID tokenizer to generate two datasets. Also, the BERT tokenized dataset was further applied on PCA and LDA to finally yield us 4 datasets to work with. Now we'll quickly go over the implementation of different classifiers. The first one being decision tree classifier. It was implemented using scikit-learn's library, and we varied max step parameter to obtain the maximum accuracy. Similarly, for random forest, the number of trees parameter was varied upon, and the optimized accuracy for each dataset was determined. Similarly, for support vector machine, for each of the 4 datasets, 4 different kernel combinations were tried, which included linear SVC, which means no kernel was used, linear kernel, polynomial, and RPF. For naive bias, similarly, hyperparameter tuning was done using grid search, and different accuracies were reported. The same is with perceptron. The optimum values of learning rate and tolerance were determined, and the highest obtained accuracies from each dataset were reported. For logistic regression, the optimum value of regularization parameter was to be determined using grid search, and then the corresponding highest accuracies were recorded and compared. Overall, if we need to summarize it in one table, we can see that for each of the classifiers, the mentioned dataset yielded maximum accuracy, and the maximum accuracy was reported in the third column. We can see that TF-ID generated the maximum accuracy in 4 out of 6 datasets. LDA performed the best for decision trees, and BERT tokenized dataset performed the best for perceptron. The highest accuracy was 71.5% obtained using TF-ID tokenized dataset. Also, we performed ensemble learning and boosting. In ensemble learning, what we did was we returned the model values of the labels predicted to finally determine the final prediction. In boosting, the incorrectly classified samples were given higher weights than correctly classified samples to further improve the accuracy. Thank you, and now we'll quickly go over the GitHub repository.
Yes, so hello, this is Krishna. So this link will redirect us to the GitHub repository where we have maintained the code base. So the repository basically includes our classifiers, the dataset CSV files, some images and web app related things, as well as our index like web page for the project, which we can see here. This is the web page for the project, and we also have a demo page where user can input values such as user text, let's say age being 20 and time being noon, and we can get a prediction based on the value. Similarly, if we have some negative sentence, we'll get a negative prediction. So this is yet to be deployed, but it will be deployed soon. Thank you.